Hello, I hope you're doing well, and now we're gonna make the problem number 44732, highly divisible triangular number. So what we have here is like triangular numbers. So let's imagine that we have 1 and then 2, and yeah, 1 plus 2 is 3. So that's how we get the second triangular number. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10, and we can keep going. So that's the way we create triangular numbers. Also, we can get the divisors for these numbers. So for 1 is just 1, for 3 is 1 and 3, for 6 is 1, 2, 3, 6, and this goes on. What they are asking us is to get a function that returns the value of the first triangular number to her over d divisors, and d will be our input. So for example, if we get d equals to 3, our answer should be 6, because that's the first triangular number that has more than 3 divisors. We get d equals 4, our answer is going to be 28, because that's the first triangular number that has more than 4 divisors. And that's the way we should approach. Let's see if we can make this into code. And yeah, that's it. So we already get the code. It was actually quite interesting. It was a bit challenging. But yeah, all the code can be put or can fit in a screen. So it was not that long. What we needed to do is the following. We just needed to get like um, a while command. So this while loop is gonna work until we get a triangular number that has more divisors than d, or input is d. And on the case that we have, for example, d equals to 0, we added this. So our answer is gonna be 1. Number is like the current natural number that we are gonna keep going. So for example, we start with 1, and if that doesn't satisfy the condition, we get with 2, and then we get with 3 and 4, and that's why number is here. It starts with 1 and then it keeps going. To get the triangular number, we use define k, which is a formula. So for example, we have, for example, 5. We will get 5 times 6 over 2, and that's 15. And yeah, if we add 1 through 5, we also get 15. So this formula is better because it's straightforward, it's more fast, and we don't need to use and for. Counter is the number of divisors at the moment we are going through this code. And yeah, this while or this loop is going to stop when the number of divisors is bigger than our input. That's why there is this condition. We get a triangular number and we start with a vector. The vector is going to have 1, and also it's going to have the triangular number, because that's our first divisor that we're going to have. After that, we get a 4, and we start from 2 to the seal of the square root of the triangular number. So we do this for also for primes. When we want to have primes, we also do this. So we don't have to check through all the numbers, we just check until the square root, and this is good because it's also very fast. If we don't do this, we will take too much time for bigger numbers, like of the level of hundreds or maybe thousands. And yeah, how we know we get a divisor in this case is because of this condition. If k, or triangular number, of over or suppose or hypothetical divisor is the same as the round of that number, then that happens. That's two divisors. Just for example, take 3 and 2. K is 3 and I is 2. Uh, we will get 1.5 here, and here we get like 2, because those are not the same, those are not divisors. So that's the way we can filter the divisors. Finally, we just get like our hypothetical divisor that is a divisor, and also the other pair. The other pair is gotten like dividing the triangular number over this divisor. So for example, we have 6 and we have 2, and that's the same as the round of 6 and 2. 3 equals 3, and yeah, I is 2, and then k over I is 6 over 2, and that's 3. So we get 2 and 3 as a pair of divisors. Finally, we will get a vector which could have a lot of repeating values. That's why we first sort the vector. So we get the smaller numbers first, and then it keeps going on ascending order. And we use this. This is a command to get just one value if we have a vector with repeating values. It's very good. It also let us know how many divisors we get because we're gonna use a length for counter. So yeah, with counter we already know the number of divisors is just the length of the vector, and if this condition doesn't happen, we keep going. That's why we get number equals number plus 1. So we can go from 1 to 2 to 3 to 4, etc. until the condition is satisfied. Our answer is just the last value of the vector. And yeah, that's it. That's it. And I hope you have a good night, and yeah, we keep going, and good luck.